This is an applied Newton's second law problem that involves friction. So I have a 2 kilogram block sliding on a rough horizontal surface. So I'm going to start by just collecting what this problem gives me. I'm given the mass, and I'm given that it's a rough surface, which means it will have friction. As a reminder, friction is the coefficient of friction times the normal. And we are told that there is a force of 4 newtons that acts parallel to the surface, and it is applied to the block. And then we're told, with all this going on, that friction, that force, the block accelerates at 1.2 meters per second squared. Now, this problem has a second part. Now we're going to change the force on the block to 5 newtons, and we want to figure out what the acceleration is now. Well, certainly we can think that with a bigger force, 5 newtons instead of 4 newtons, we are going to have a bigger acceleration. And that's what I'm looking for in this problem. All right, so I've identified and gathered all of my known values that I'm given in the problem. The next thing I'm going to do is sketch it. And now I am going to write Newton's second law in the x direction. So I'm going to sum up the forces in the x direction. That will be my force of 4 newtons to the right, so positive, minus my force of friction, which goes to the left because friction always opposes motion, and that equals mass times acceleration in the x direction. Hey, we have everything in that equation except for friction. So let's sub in and solve for friction. I am going to note really quickly that there are 2 other forces that are acting on that mass, the normal force and the weight. I did not include them in my initial sketch because I knew that I was just going to sum the forces in the x direction, and those 2 forces, the normal and the weight, act in the y direction. But as a side note, I could sum the forces in the y direction and find that the normal equals the weight in this problem. Okay, now I'm ready to tackle the second part of this problem. I want to find the new acceleration that goes with that new force. I'm going to sketch again. And I'm going to draw the free body diagram off to the side here, identifying all of the forces that are acting on that mass. All right, and now using my free body diagram, I am going to apply Newton's second law in the x direction. So that means I'm going to sum up the forces in the x direction and set them equal to mass times acceleration in the x direction. I have F nu. I have the force of friction from the first part of the problem. That hasn't changed. I have the mass, so I can solve for acceleration. And there you have it, 1.7 meters per second squared, which is greater than the original acceleration of 1.2 meters per second squared.